flexible NATS deployments can be. Over to you, Colin.
All right, thank you. And I really appreciate the opportunity to speak here. Thank you so much. And I'll dive right in here. Can you see my screen? Or can you hear me?
Yes, we can hear you, Colin. And this
great.
Go ahead.
All right, so today I'll speak a bit about the flexibility of NATS from edge to cloud, and then walk through. It's a really cool use case that we're using NATS to help enable. So first, a bit about myself. I've been in the distributed computing space for a long time. I started way back in the day with Talarian SmartSockets. That was telemetry with satellites and kind of expanded to a number of horizontal markets. And then following that, I was a senior architect on TIBCO EMS, Rendezvous, FTL, and PGM, mainly starting at training floors and then expanding out from there. I've been lucky enough to do solutions architecture for some very, very large-scale distributed systems. I was a former principal engineer on NATS and then product manager for quite a few years. And recently, I kind of spun out and I started a company called Luxent Solutions. Pardon me. We're a systems integrator, generally focusing on high-performance systems in the edge and cloud. And I do want to say I am a bit biased, but when it comes to edge deployment and tying edge to cloud, NATS is actually my clear favorite. Now, I'll go into why in this presentation. So what makes NATS so flexible for edge computing? Well, it runs in many, many different places. You have multiple usage patterns in terms of APIs and how your applications interact with each other, multiple data storage patterns, and you can get very highly flexible topologies. So the NATS server can basically run anywhere, which makes it fairly unique compared to other servers of other messaging products. It's the binary is about 20 meg. There's no external dependencies, nothing else to link, no other pieces that you really need to run. It has very low memory footprint and is highly performant. On an old laptop of mine with Core NATS, I can still run about 2.5 million small messages a second. I think I was using 64-byte messages, 2.5 million messages a second, and RSS on the server remains under about 10 meg. A lot of users don't necessarily need that performance, but what that means is you can do so much more with less hardware and less resources with the NATS server. And this lends itself to having many deployment options, whether you're in Kubernetes, deploying with Helm, Docker deployments, running on an operating system on bare metal, or running on cards on devices in the field. And the beauty is that from an application standpoint, it's always a NATS server. It doesn't matter at all about where NATS is deployed. So NATS has multiple communication patterns. You have your request reply, which is like HTTP, and then publish subscribe, which allows you to do fan in and fan out. I won't go into a lot of detail here. I'm sure it's been covered earlier. But then we also have materialized views of persisted data. So this is basically, you can store data in streams as a KV store or as objects. And this allows you, these primitives in persisting data in multiple ways and the primitives in how your applications can interact with each other allow you to build just very, very robust applications that communicate from edge to cloud. And another point, I'll talk a little bit more about this later, but authorization authentication can be bifurcated from topology. And this is very important later on. As you start to scale, as you change to the back end, you can maintain your same authentication scheme, but then change your back end, allowing you to scale as you need to. When we deploy NATS, I tend to think of a deployment in building blocks. So everything you deploy, outside of monitoring and additional tooling, but the minimum you need to deploy are one to a series of NATS servers. And you can deploy a single server. I call this a singleton deployment. This is NATS running on an edge device. I use this all the time in my development. I just spin up a NATS server on my laptop. Then when you take these servers and you cluster them together, you create a NATS cluster, and these are multiple servers together acting as one entity. The use case here is high availability, fault tolerance within a region. You can cluster NATS servers over multiple regions. There's a very more specific use case for this around Jetstream that I could probably spend an hour on just in itself. But an important note in that being able to do that kind of illustrates that while you have a NATS topology, it doesn't necessarily have to match what your physical network looks like. So you can have a logical view of NATS sitting on top of a different physical network. And sometimes this gives you a little bit of additional flexibility in terms of how you're going to deploy your applications. So you have your cluster of NATS servers. When you cluster these together, you create a cluster of clusters. This is a super cluster, a multi-region deployment. And then you have another way of connecting a NAT server or a cluster of NAT servers into another cluster, which is called a leaf connection, a leaf node. And this is where you create a security context. Leaf node connections are used for edge deployments where I've got something out in the wild and I don't want to give it access to my super cluster without some sort of auth-z restrictions on it. They're good for remote installations, but the other thing that they're very good for is you can configure authorization to restrict traffic significantly on a leaf node, which comes into play when you have a lot of data sovereignty issues. If I have data that cannot leave, let's say it's a hospital, it can't leave this building, or it's a region or country and it can't leave, you can have a cluster in that location and a cluster in another location, have those clusters connect via leaf nodes rather than gateways, and really button down what traffic does, thus using NATS in your data sovereignty policies. When you take these building blocks and put them together, you can create some very, very complex topologies. I want to say arbitrarily complex topologies. You might have a complex, I call it a complex edge. You might have a data center somewhere running someplace with applications connected, with a leaf node connection going into a super cluster. You can have a very, very simple edge deployment. Might be a NAT server running on a card or NAT server running on a laptop. And these applications are all driven. It doesn't matter what this topology looks like. These applications have access and communicate with each other so long as auth-z supports it. And in fact, you can even, if you wanted to, move an application. And again, so long as auth-z allowed it, you wouldn't even really notice a difference. So this makes NATS extremely flexible. So I want to talk about what we're doing with NATS with a project called Edge AI. Steve Ward created the project. He gave me, it's underway right now. He gave me permission to speak about it. So what Ethic AI is doing is it's an approach to developing and using AI in law enforcement. And what we want to do is build tools that will help promote fair and constitutional policing. So in essence, we're using body camera video and audio as inputs, and then coordinating with a couple services on the edge. The edge will be a car, and I'll get more into that in a second, with object recognition and audio processing. And that inference will detect a variety of situations that provide outputs to go to a law enforcement officer. And this is in real time. So obviously there's some real technical challenges here. The biggest one is that mission critical information has to be presented to an officer in a timely manner and in a manner that doesn't interact with his or her services. And then the other technical challenge is that the system has to be autonomous. It's got to work where there's poor or no connectivity. So for a higher level view of what we're doing, we're using NATS here as the information, as the way to exchange information and access microservices in the cloud, which I call deferrable microservices, meaning if the edge can get to it, great, we have services to augment what the officer's doing. If the edge can't, the edge can still work autonomously. And we have a training model that uses external data sources, as well as we're going to reuse some of the data that we garner on the edge and for some reinforcement training. As we get to the edge here, this is what the edge kind of looks like. We have a worn body camera that's got video and audio. Longer term, we're also going to use other things, telemetry from the car, that sort of stuff. But first pass, worn body camera, and then we'll have ML vision, object detection. So far, initial tests have been very promising here. From there, we give that to some sort of application that does situational analysis. This application needs to be very, very predictive. So I doubt we're going to use any LLM, at least in the human loop here. And then we have audio augmented reality or text that might go to the officer's laptop in the car. And all of these components are working together using NATS on the edge. So any green arrow here is NATS, and this can all operate autonomously, doesn't require any external connectivity. And when we separate out these components on the edge, that allows us to leverage multiple cores, CPUs, GPUs, allows us to distribute the workload for these very, very intensive inference. And then if we have to do language generation or anything, we can. However, when there is connectivity to the cloud, we use NATS to access the cloud from the car with additional services. And first pass, we're looking at identification services, looking at using mugshot. So the video on the officer's camera identifies a person, and we can take a snapshot of that person, cut that down into something that could be comparable to a mugshot, and then compare that against wanted posters, mugshots, missing persons, to be able to provide this contextual information back to the officer. So the officer might be making a stop, he's talking to people, and out of band, this goes and checks, and then it might notify the officer saying, hey, there is a missing person here. And it sends a picture to his watch, says, here's what this missing person looks like. And he can then make the decision to maybe call other officers or ask more questions in the field. And then how we prompt the officers is we want to provide text prompts. Oh no, I'm going to change prompts. That's very overloaded when we're talking about AI. How we're going to surface information to the officer is using text. In some cases, we may use audio. We'll use text-to-speech to notify the officer. So that's where we're going with things. And I just have to say, choosing NATS for this, we chose NATS for this because it is the ideal distributed communication technology when you're seamlessly bridging edge and cloud applications and service. It allows you to operate autonomously at the edge. There are many use cases where this happens. If you squint, this use case is very similar to like a connected car use case. Or manufacturing use case where you have a lot of components working in a factory floor, and sometimes these factories lose connectivity to the cloud. This covers multiple communication patterns. NATS I didn't go too much into this. NATS provides a more secure solution. So as you're bundling up these different technologies, or different patterns, like a KV store, you're bundling up request reply with pub sub. You can do that in one technology with NATS, which is effectively one communication plane. And that allows you to eliminate crossing security contexts unnecessarily. And it also lends itself to being more observable. So you can have just awesome opportunities to observe NATS. And when there's connectivity, even observe remotely what's going on in the edge of the cars. Makes it very easy to debug. And it actually shortens time to market because you're able to really see what's going on. Hey, I want to thank you so much for your time. If you have any questions, think of any questions later, certainly feel free to contact me. I'm Colin at luxonsolutions.com or I'm on LinkedIn. And the company that's sponsoring this, Authenticate.com, is looking for data scientists and machine learning engineers. So if you're interested in this project, certainly reach out, and we'd love to talk to you. So at this point, I'd like to open it up for any questions you might
have. Any questions, folks? We have one.
Yeah, hi. This is Amar here. So the edge, so the edge at AI. This concept is means the AI is already pre-trained, and then it's only doing inferencing at the edge, right? Based on the audio, video, whatever input. That's my understanding.
Correct.
Okay.
Correct. So for video, we started experimenting with YOLO 7, and we'll also probably look at YOLO 8. We're going to use a model and then pre-train it to kind of fine tune some of the other models. You'll see I've got, I've got a tape measure here. I was actually experimenting last night on my computer here as to what it can detect. And yeah, that actually poses a interesting question that, let's say it does detect a firearm and it wants to notify the officer right away. What confidence does that detection need to be? What's okay? Is it 75%, 80%? And what we have is on the team, we have a series of, we're lucky enough to get a psychologist who's worked with LAPD for 25 years. We have access to law enforcement officers in the field, and then also other sociologists to work with us to help determine this. I'm just doing the technical stuff, and that turns out to be the easiest part of this project. But yeah, there's a lot that goes in. And sorry, long answer. We are using pre-trained models, and we're still actually evaluating what models and bootstrapping in some areas at this point.
Thank you.
Any other questions? Any questions on the chat?
Yep. Hey, Colin, there's one question on the chat from Tejas. Can you tell some pros and cons of using NATS compared to other technologies in this maybe communication space?
Sure. It really depends on the other technology. If let's compare it to the basic technology. Let's say I tried using HTTP for this. Within the vehicle, that would work out nicely. Except that I don't quite have the same observability. If we use something like K3S in the vehicle, you can use a service mesh to get some of that observability. Those are additional moving parts. I like to remove as many moving parts as I can from the edge because it's more expensive to deploy and there's more that can go wrong. But let's take that HTTP. Then you have HTTP back to your central, and then you have a whole coordination issue. And as you scale, as you add more cars, you're going to have to scale up your microservices. And effectively, you're trying to use a pattern that fits best with PubSub with point-to-point. Now, if we bubble up and go to other PubSub technologies, let's use the most popular, Kafka right now. We use Kafka. Kafka's not the best if you don't know ahead of time how many edge devices you're going to have. So let's say you did put Kafka at the edge and you've got Kafka in the hub. You would eventually run into partitioning problems. So you do have some upfront potential future-proofing problems. Furthermore, the protocol isn't all that great. You would end up having to use something like Mirror Maker or end up using some sort of bridge from edge to cloud. And also, Kafka is not super lightweight. We're already putting so much compute on those cars. If we can save a little bit with NATS, rather than running like a massive JVM with a couple gigs of memory, if we can run NATS with 10 meg of memory and a 20 meg binary footprint install, that just makes life a lot easier. And those are just a few of the things. I can go on and on. And one other thing is NATS provides observability that you just can't get with many other technologies. I mean, it's actually truly awesome. If I set up auth correctly, or not correctly, if I set up auth to permit it, I could at any point in time when there's connectivity from let's say a development center, reach out and see exactly what's going on in any one of those cars at any point in time, which is extremely powerful, especially if things start to go wrong or you're trying to debug in the field.
Yep, I think that should answer your question, Tejas. Thank you so much.
I mean, I can get more specific. Happy to have a conversation if you have a particular technology in mind. some technologies are better, other things than depending on the situation, and happy to chat offline if you'd like.
Thank you so much, Colin. I think we are done with the questions. Can we have a round of applause for Colin, please?
All right. Thank you all. Thank you so much for the opportunity to present. And awesome. Have a great day, everyone.
Thank you so much.
Bye-bye.